We are now going to have a look at the link layer. The link layer sits just beneath the network layer. And while the network layer is responsible for routing your data end to end between source to the destination over the networks, it is the link layer which actually performs hop to hop delivery. So it takes your packet from one system and it takes it over one link to the next system. So basically the network layer eventually depends upon the link layer on each individual hop of the end-to-end route. So once again, let's revisit the diagram which we discussed before. So user devices have all the 5 layers, routers they have 3 layers, but the switches they have 2 layers, the bottom 2 layers, and of prime importance is the link layer. So basically link layer uses MAC addresses and link layer is used by switches. You should also note that routers they also have the link layer, but they have the network layer on top and their main focus is on using IP addresses to perform end-to-end routing. Whereas switches have MAC addresses at the link layer and they perform link-to-link delivery. So basically the difference is end-to-end and link-to-link. As we discussed, the link layer is responsible for delivering packets over a single link. Now the fundamental difference between IP addresses and MAC, also known as physical addresses, is that IP addresses are dynamic or flexible, which means that they can be changed, right? But MAC addresses are burned onto the actual network interface card. They are 12-digit numbers or 48 bits and they are burned onto the device itself. So basically they cannot be changed. Well, they can be changed in certain exceptional circumstances and there are tools to do that, but generally speaking, they're fixed. Every MAC address has two parts. The leftmost part identifies the manufacturer, the company which fabricated this card, and the rightmost part identifies this particular device or this particular card. Now let's see how the transport, network, and link layers they all gel together. We studied that transport layer offers application to application delivery, and then the network layer offered system to system delivery or end to end routing, and then the link layer performs link to link delivery. So how do they all fuse together? So say you're sitting on a system and you're running Skype and you want to send a message from this Skype to another Skype running on a different system. So what happens is that you create a message, hi, and then you send it to the transport layer. Now the transport layer considers this as the message and adds its own header, which is the transport header, TCP header in this instance, which basically contains the source port number. So you see you have the 2000 source port number and the destination port number 2300, which is the port number to be used at the destination. The Skype at the destination would be running on this port. Now this packet is passed to the network layer, which basically considers all of this as the data and adds its own header, which is the IP header, and which basically contains its source IP address and the destination IP address. Now this whole thing is sent to the link layer, which basically considers all of this part as the data, and then it adds its own header, which basically contains its MAC address. So the link header is changed on every hop. So for example, if I send a packet from my system to the next router, now for the first hop, the source MAC would be my MAC address and the destination MAC would be the MAC address of the next router. And then when that router sends to the next router, it's going to switch the source MAC and the destination MAC and so on. The IP addresses remain static, however. So when the packet is received at the destination, the link layer processes the header. It first of all, for example, checks whether am I the correct destination? Is it my MAC address which was specified? And then it does also some error checking, stuff like that. And if everything is okay, it passes the rest of the packet to the network layer, which basically performs its own processing, such as checking if am I the correct destination and so on. And then it passes the remainder of the packet to the transport layer, which basically checks that which is the port number on which we have to deliver, which in this case is 2300. So it is going to deliver this packet to Skype over port 2300. And that's how all of these layers they gel together, they work together to perform end-to-end delivery of messages or packets over networks. That concludes our lecture. I'll see you in the next lecture.